Hey guys, my name is Tori Eisenberg, and today for the article presentation I'm going to be going over one throughout the disability section. So mine is about how leap motion controller based training can help rehabilitation for upper extremities in children and adolescents with physical disabilities. To kind of break it down, so for the background, children who suffer from juvenile idiopathic arthritis or cerebral palsy or brachial plexus birth injury often have a really hard time, and these disabilities are the three most common disabilities in children and adolescents that we see today. And so what we're essentially going to find out is if this new technology called leap motion controller based training, which looks like this here, is beneficial for children with these disabilities versus conventional method rehabilitation programs. Now, I have never heard of this before going through this study, the leap motion controller method. I had no idea this was a thing, and to me it kind of reminded me of VR that you would see on like a PlayStation. And I thought it was really cool. And so essentially you have this black sensor here at the bottom, and this reads your movements from your hands and then displays that on the computer. As you can see, with this pinching maneuver here, they're actually passing this flower back and forth. And then with this person over here, they're just kind of messing around, seeing how it works, stuff like that. Now, the reason I point this out is just because they actually did this test in this study through the program to see if it would increase pinch strength. And so I thought that was kind of a cool connection there. So the purpose of the study was just to essentially see, if traditional rehabilitation programs were better or worse or kind of in line with this new LMCBT, the leap motion control-based training programs. And so basically what they did is they pulled in 103 patients from ages ranging from 5 to 17, and these patients had at least one affected distal joint in their upper extremity, involving their wrist and finger joints. And so it was an 8-week program, and they went for 3 days a week. It was a completely randomized trial in regards to the groups. And so group 1 was going to be using the LMCBT technology, versus group 2 was just going to be doing conventional treatment. So the conventional treatment essentially used the DeRose Hand Index and Jepson-Taylor Hand Functions test as their primary outcomes. That was going to be kind of their baseline to which they compared the results after testing to. So another thing they did too was like a 9-hole peg test. And so this tested their precision with their pinching mechanism to put 9 tiny little pegs into small holes to see how accurate and fast and quick they could do it. And then they also had other assessments of grip and pinch using these tools here, which is kind of cool as well. So what they did for the LMCBT, so like I said, they made little games actually out of this technology, and one of the games was where they had to pluck flowers back and forth like in this image here. Another one is where they used their grasping mechanism with their hands to stack blocks. They had another one where they would poke like a bunny wherever it jumped. And so they had other games that essentially used the same functions as the conventional methods, but they did it in a different way. And I thought that was really cool, and I think it's very interesting. And so if we were to look at the results here, a little bit of background information about this. So the N, which is up here at the top, represents the average. So for the LMCBT group 1, the average is 18 versus the conventional therapy methods, the average there is 25. So BT right here represents before treatment results, after treatment results here for AT, and then the delta is the difference between the two. So it is AT minus BT here. So if we were to look, this is for children suffering with juvenile idiopathic arthritis, or JIA, excuse me. So their hand grip was here. So it started before treatment as 12.72. The tip grip here was 1.64 and the lateral grip here is 6.13. Now I know that hand grip, tip grip, and lateral grip are not the only things up here. However, these were the 3 things that we actually learned about in class, so I thought it was just more relevant. So before treatment, they weren't quite at the average, but if we look after treatment, group 1, those who did the leap motion controller, actually had an average of 20.79, so already it increased up 8 points, which is kind of huge for the hand grip. Now the tip grip, it still jumped from 1.64 to 3.46, and then same in the lateral grip, you started at 6.13 and that jumped up to 8.03. All of these were still improvements, which is huge, and it's kind of cool to see that the hand grip actually, beat the average. Now in conventional methods, the average here was 25. So before treatment, hand grip was measured as 16.17, tip grip was 7.39, and then lateral grip was 3.27. Now after conventional treatment, our results were 23.9, so really close to 25, that average there. And then for tip grip, it went from 7.39 to 8.58, still improvement there as well, and lateral grip is 3.21 up to 5.63. So as you can see, even though these numbers were still higher than the LMCBT group, there were still huge improvements between either group 1 and group 2 for JIA. Now if we look at cerebral palsy, the results here, CP, the average for both of the groups, group 1 and group 2, were 15. Now for the leap motion controller based training group, the hand grip started at 7.8, tip grip was 1.30, and lateral grip is 2.65. After treatment for the leap motion controller group, it was 9.96 for hand grip, 1.70 for tip grip, and 3.66 for lateral grip. So again, we had some big improvements here, 2 points here, 0.45 here, and 1.01 here. So there were still improvements, not quite the average. But if we look at the conventional therapy, hand grip here starting at 8.72, tip grip is 1.72, and lateral grip is 2.73, versus after therapy for conventional methods, it was 11.40 for the hand grip, 2.08 for the tip grip, and then 3.56 for the lateral grip. Again, still improvements, not quite as, positive as the JIA group here, because these were some really big improvements, but definitely still big from where they started. Now, lastly, these are for the BPPI group here. The average here is 9 for the leap motion controller based training, and the average for conventional therapy was 10. So for the hand grip, we started at 5.70, tip grip was 0.91, and lateral grip here was 1.80 for before training. And then after training, it was 6.84 for hand grip, 1.18 for tip grip, and 2.08 for lateral grip. Still some improvements, not quite close to the average, but again, as long as there's a positive outcome, they were willing to work with it. So the average here for the conventional therapy group, or group 2, was 10. So we started before therapy with, for the hand grip, 5.74. Tip grip was 1.13, and lateral grip is 2.21. After therapy, we got 6.57 for hand grip. For tip grip, it was 1.58, and lateral grip 2.41. So again, these were still improvements. Only one of them broke, 1 point, but they were still improving. Now, the trend here essentially is the same throughout all groups, and that is that the baseline results of the LMCBT groups were worse, or not quite as high in almost all scores compared to the conventional groups. However, the improvements with the upper extremity functions, though, were better in the leap motion controller-based therapy groups than conventional groups, and especially in regards to patients with JIA and CP. These two groups here had probably the best improvement compared to, or along with JIA groups, and then compared to BPBI, but there were still improvements. So I just felt like the study was very interesting. Here's the source here for where I got it from. But yeah, thank you guys so much for listening.